Hello again. In our last lecture, we started talking about key management in PGP. Remember, there are 4 different kinds of keys which are generated. Well, let's talk about how they're managed as opposed to how they're generated. Right, so recall that session keys and these passphrase generated keys are really used once and then thrown away. It's the public and private keys that you have to worry about because they're persistent. They're the ones that you have to store somewhere and maintain the security of, at least for the private keys. For the public keys, we don't care. Anybody can see those. And also, it may be the case that a particular PGP user will have multiple public and private pairs, public and private key pairs, right? So that means you don't just have one public key and one private key. You may have a number of these. So then the question becomes, if I'm communicating with a whole bunch of different people and somebody sends me a message encrypted with one of my K public keys, how do I know which public key they used? Well, I could just try them all until I find the right one, but that wouldn't be very efficient. So what we might do is the sender might send the public key along with the message. That'd be okay, except these public keys tend to be pretty long. They may be 2024 bits long, for example. So that would be inefficient. Another thing that we might do is we might associate a unique ID with each public-private key pair and then send the ID along. But that would require, that's a management problem because it would require everybody that I'm talking to know the IDs of all the keys that they're using. So what actually happens in PGP is you generate an ID for the pair which is likely to be unique but may not be. And that ID is the last 64 bits, the least significant 64 bits of the public key. And so when someone sends me a message, they actually send me that key ID along, and then I can just do an associative search on my list of keys to see which one matches. And with very small probability, there may be a collision. Okay. Where do you keep these keys? Well, each user in PGP has 2 key rings, one called the private key ring and the public key ring, as you might expect. On the private key ring, that's where you keep your own private keys and information to identify them. So you'll have the corresponding public key, you'll have this key ID, which is the last 64 bits of the public key, you'll have a timestamp telling you when the key was generated, and you'll have a user ID. And so when you want to access one of these things, then you can use either the user ID or you can use the key ID. And then, so those are on the private key ring are the keys that you have. On the public key ring are the keys that you store with the people you want to communicate with. So you might have a public key for Joe or a public key for Sally, right? And so then you just store the public key along with a user ID, a timestamp, and a key ID, which again is just the least significant 64 bits of the public key. That way, if you want to talk to Joe, for example, you just look on your key ring and get the appropriate public key associated with Joe, or if you happen to know the key ID, you can use that. Okay, now remember, we said in our last lecture that the private keys are stored encrypted. And the way this works is anytime I need to access my private key to authenticate a message or to decrypt a message, what PGP asks me for is to type in my passphrase. I type it in, that's hashed, and then the result of that is used to encrypt or decrypt my private key. And that's just an additional layer of protection because the security of the private keys is what the security of the entire system hinges on. Okay, how do you know that the public keys that you have stored on your public key ring are legitimate? That is, that they really belong to Joe or Sally or whoever. Well, the key is stored with what's called a key legitimacy field, which is some measure of how strongly you believe that that key really belongs to the person you think it does. If you remember a number of lectures back when we talked about certificates, we said the big problem with certificates is making that binding between a user's identity and a public key. Well, you have the same problem here, and the key legitimacy field may store certificates that allow you to verify or say that someone else has vouched for the authenticity of that binding. And that's an error-prone process, but it's a necessary process in a system like this. Okay, finally, it may be possible to revoke a public key, either because you suspect that a compromise has happened and somebody may have gotten a hold of the corresponding private key, or just because you've been using that key for a year and you decide to change it. And so what you do in that case is you send out what's called a revocation certificate. You can't force anybody not to use that key, but you can at least advise everybody that you're talking to that you would prefer if they not use that key from now on. Okay, so what have we said? We said that each PGP user maintains this public and private key ring on which they store their own keys and the public keys of anyone with whom they correspond. So we have these two separate rings, and the private keys are protected by encryption. The public keys are stored with certificates to attest to their trustworthiness. This is the key legitimacy field that we talked about. And keys can be revoked. That is, you can revoke a public-private key pair, but you can't actually force anyone not to send you messages encrypted with that, though you can refuse to accept them. Thanks.